The first unit, that was the introduction. It's having different topics. The first topic is the major consideration in the electrical machine design. So while you are considering the electrical machine design, the electrical machine is consist of five main parts. One is the electrical circuits, right? Then the magnetic circuits. The EC is indication of electric circuit, and the magnetic circuit, and the dielectric circuits, and the dielectric circuits, and the mechanical parts, right? So the electric circuit means if you are considering any machines, it's have the conductors. Okay, in the conductor we are giving the supply to the machines. If you are considering, we are basically focused on the machines, it's coming under the motors and the transformer. So the motor, it's have the winding. Similarly transformer also is having the two winding. So if you are considering the transformer, it's have the two different winding. One is the primary and another one is the secondary. So how you are saying the primary winding, you are giving the supply, so that was the primary. While you are connecting any load, that was the secondary winding. Based on the turn ratio, it may getting varied, right? So while you are considering this part, this is the core, this is the conductor. Okay, the conductor is formed in the form of winding. Okay, number of turns which is present in the primary winding, that may intimate like N1, that was the N2. So the N1 is how many turns, number of turns it is containing. Based on that, it may operate like either step up or step down or isolation, whatever. Based on our user requirement, we are designed like that, and we are selecting the based on our application, we are selecting the most appropriate one. Okay, anyhow, in that, this is the apparatus, it is the one of the apparatus. This, if you are consider, it's containing the electric circuits. Which is the electric circuit? These windings and the power supply and the conductor, these all considered as the electric circuits. Okay, this all considered as the electric circuits. Suppose if you are considering the magnetic circuits, so the magnetic circuits, the electric circuit in the sense we are giving the supply. In the conductor alone, we are considering how you are making the connection, how you are interlinking all the components. Okay, how you are passing the electricity, that is called the electric circuits. So how magnetic circuits, because we are dealing with the electrical machines, right? So it's have the winding. Okay, the magnetic means, the according to the Faraday's laws of electromagnetic induction principle, the magnetic circuit we are consider, right? Once we are giving the supply in the primary winding and the secondary winding is direct, there is no direct connection between the primary and secondary winding. It is the magnetically it is connected, yeah. So while you are giving the supply, it's formed the electromagnetic field, right? If you are consider any conductor, the form of coil like this, it will be formed like this. Here the north pole and south pole, that is the flux lines, it will form like electric field. Then the electric field is converted into the magnetic circuits. Whatever the flux is induced here, right, EMF, that has been transferred without any connection, without any direct connection. The generated flux or induced flux, it is reach out to the secondary winding. So that is called what? That is the magnetic circuits. So in that you have the dielectric circuit. In the sense, what is it? What is the meaning of dielectric medium? That is the insulation. So between this conductor, we are making the coils. Suppose if you are consider the single phase, right, you are having the phase and neutral, and you are making the turns. In the turns itself, it's have the insulation. Do you know that the conductor, it's have the insulations? While you are making the winding, it's have insulation. That insulation is called, that is the dielectric medium, right? Dielectric circuits, that also a dielectric circuit. And after that, here you are making the connection. No, this conductor also have the insulation. This insulation we can call it as insulation. Wherever we are connected, that insulation we can call it as dielectric circuits. Okay, then the mechanical parts. What are the mechanical parts? You are using the core here, right? And this all the winding, it's need to carry the, while you are making the winding, so it's need some support. Straight away we can't put the winding, right? So winding it's need to hold anything, any type of mechanical parts, right? That is the high tensile strength based mechanical elements like steel, right? Steel plates, that they may connected here, so it will be produce the mechanical support of the machine. Okay, if you are consider the same thing in the rotating machines, like, so that was the rotating machines. Here the stator, that was the primary winding. Then here the rotor, some machines we are having the winding in the rotor. Based on the classification, it may have the winding. So while you are giving the supply, here this was the electric circuits in the stator winding and rotor winding. You are giving the supply now. Wherever we are giving the supply, that circuit all it is come under the category of electric circuit. Then after giving up supply, the based on your input voltage, it will be formed as the magnetic flux, magnetic field. Okay, it has been transferred into the another medium, that is the magnetic circuits. So it's while we are making the connection, we are using the insulation. That insulation is a dielectric medium, so it's need for mechanical support. That was the outer face, that is the yoke. Okay, yoke, it will be the mechanical part of the machine that will be produce or provide the mechanical support of the entire machine. Listen it. So this all it is under the category of principle of electrical machine design. So while you are considering the major consideration, before that you need to know the basic principle of machine design. You are going to design the machine. So while you are designing the machine, which are all the parts, which are all the circuit is essential in the machine design, that you have to know. Okay, in that category it's having the electric circuit, magnetic circuit, dielectric circuit and the mechanical parts. That is the primary, that is the principle of electric machine design. Okay, if you are considering our topic like that, major consideration of electrical machine design, in that it's have many things, that is the cost. Then second thing, what is that? Durability. Then third one, the performance criteria. Performance criteria are user specifications. Performance criteria are user specifications. Okay, write it fully. Then the last one, that is the temperature rise. If you want, you can add it. The temperature rise, they are given. Sometimes they may consider in this separately. Okay, because the temperature is the very much essential factor for while you are involving in the design process. That is why maybe they consider separately. But actually it will come under the category of durability itself. We are considering the temperature and the insulation based on the insulation cost and insulation material we are considering. So we can put the heading for the major consideration of electrical machine design. So in that, the cost, durability, then the performance criteria or user specification, then the temperature rise. So the cost, how we are considering is the cost was a major consideration, because while you are designing any of machines, you need to give quality wise, you need to improve, and cost wise you need to reduce, right? So then only the customer they may are getting attraction, then they are going to purchase the product. Normally it will be applicable for any design, right? But here, while you are purchasing any machines, so the cost it should be the optimal, and size it should be optimal, right? Then while you are the size and all, it will come the design process itself. If you are reducing the size of the machine, the mechanical part and the conductor size and the conductor phases, so that all it will be getting reduced. So while you are reducing the size of the machine or usage of steel, if you are reducing the cost, it may getting reduced. Instead of steel, some cases they are using the resin materials, right? Synthetic materials, resin materials they may used. Okay, so the cost was one of the essential factor. Then the durability, it will come under the category of various environmental conditions, saturation, vibrations, it all applicable. Then here the performance criteria. Performance criteria, we are considering the power factor, right? Then torque, speed, right? Then the efficiency, that all we are considering here. Then temperature rise. The temperature rise, it is the main factor for of any machines. While you are giving any of a load in the particular machines, definitely if they are definitely after purchasing of machines, they won't put many machines in ideal, right? They are involving somewhat specific applications, right? So while they are connecting the applications, that is the load, while they are connecting any of load, the temperature it may getting increased, right? If you are running your fan without any blade, temperature it will be a very low. If you are connecting the blade, right, it will be the load. So while you are adding the load, temperature is gradually increased up to steady state temperature. Okay, so while you are giving the load, based on the load, the temperature also increase up to the rated current. right? So if you are operating the machines up to the rated current, the temperature it will never keep on increase. Suppose the temperature is keep on increase, what it will happen? The finally the machine it will be getting damaged, right? But it is any material, because we are using the rotational parts, as well as while you are connecting the load, the flow of current is directly proportional to the load. So while you are connecting any load in the machines, the current flow is keep on increasing. If you are keep on increasing the load up to the rated current, the current flow also getting increased. So flow of current if increase, the temperature also getting increased. So that is why the temperature was the major factor. It's purely depends on the load as well as load current. Okay, so that was the major consideration in the electrical machine design. So while you are making this design, it's have some limitations. Okay, what are the major limitations we are consider? The saturations, vibrations, and material selections, insulation selections, and the transportation, right? Then the power factor, right? Then is efficiency, right? Efficiency, then the specifications. Suppose some users they may ask the specifications, they may fix it based on their applications load, right? They may fix the specifications, right? So suppose that particular specifications we can't able to manufacture that particular machine, or we can't able to